Okay.
Introduction to Matplotlib.
Right. So introduction, and there are three files actually. One, some three numbers, consecutive numbers. You check, you will finding it. Okay. Okay. Let's see now. Okay. Let's get started. Okay. So what will you do is, in this first linear regression is the one that we'll discuss, and before that I'll first talk what is machine learning. Okay, and what are we supposed to do in the entire ecosystem. Okay, first thing is, let's understand what is machine learning. Okay, so go back to the time when you were a kid. Okay, how were you trained anything? Typically your parents taught you by showing that is a cat, that is a dog, isn't it?
You started recording?
Yeah, I started.
Okay.
Okay, and I'll give both of you permissions to record. Okay, so when so talking about machine learning, so when you were trained how to identify cat and dog, nobody really told you that find four mustaches in the cat or find a tail in the cat, nothing like that. Nobody told you the rules of identifying a cat. People just showed you that this is a cat, that is a dog, and whenever you were making mistakes, somebody was correcting you, isn't it?
Yeah.
Okay, so from the childhood time we have been, I mean, the reason why we can do complex things is because we have been trained by examples, isn't it? We're not set up rules that this is the case, then this is this is it, if this is the case, then this is it. We are more trained by examples. Okay, and because our mind finds a logic. So somebody, if you're shown when you're a kid, right, just imagine you're a kid, you have been told that is a cat, that is a dog, your mind creates a logic to identify given an animal, it will tell you if it is a dog or not. Understood, right?
Yeah.
Okay, so what is machine learning? Machine learning is developing a software which can do what our mind did. Okay, machine learning is typically developing a software which can learn by example.
Yeah.
Okay, learning software is a software can learn by examples. Okay, now coming to, there are two types of it: supervised and unsupervised. Okay, supervised, this is one type of machine learning, and unsupervised is another type of machine learning. Supervised is typically, understood what is machine learning. Now supervised is where you are given for example, when somebody tells you if this is the case, that is the result. If this is the input, that is the output. If this is the input, that is the output. And at the end they will ask you, if this is the input, tell me the output. Got it, right? Okay, so let me give you an example of supervised machine learning. Okay, so understood what is machine learning. Now what we'll do, there are two types of machine learning: one is supervised, one is unsupervised. Okay, supervised is of various types. One is regression, one is classification. Okay, unsupervised has a clustering, dimensional reduction. Okay, so those are your unsupervised. Now let's understand a little bit about supervised machine learning. Okay, so one of the technique is regression. Okay, let me explain what is regression. You'll understand what I'm trying to say. Okay, so I'll be using some slides of some pretty famous professors and university. These slides are shared, so if you want, you can download the stuff and use it. Okay, so I'll go a little bit mathematical, as a just to explain various things. Okay, so let me explain few things first. First, what we want to do. So, given a suppose you have given a data set. Okay, you'll be given a data set like square footage and the price of the house. Okay, that means you will given a lot of data: square footage and height. What is square footage? The size of the house, and how price of the house. You are given some data. Okay, after seeing some data, if I ask you Okay, now tell me if the footage is square footage is this, what is the price of the house? What is the type of problem this is? This is a regression problem, because and this is supervised problem. Okay, first let's understand what is supervised machine learning. Supervised machine learning means you have been given that input data, output data, you find the logic, and later on using that logic, given any input data, you should be able to find output data. Understood what is supervised machine learning?
Yeah.
Okay, that means you are giving input and output both. So there are many types of supervised machine learning, like given the size of tumor, you have a tumor, then identifying whether this is malignant and benign or benign. That means, is it cancerous or not cancerous? Okay, given the type of tumor size, you have to identify the cancer. So what will happen? You will train your machine with lot of tumor sizes and the information whether they are cancerous or not cancerous. You'll be training your machine with lot of this information. Okay, you'll be training your machine with lot of this information. Once your machine is trained with all this information, okay, then given a size of tumor, it will be able to identify whether this is cancer or not, isn't it? Okay, this is supervised. Okay, this is supervised. Supervised means you are giving some information, you are giving some label information as well. That means it is under supervision. That is why it is not supervised. One such case is this square footage of house. See this diagram here. Okay, in this diagram you see square footage here, right? Okay, you see this as square footage here. This is the price of the house in $1,000, right? So so all this cross here means given a square footage of this is the price of the house. Understood? Okay, given a square, these are your data that is available to. Given the square footage of this is the price of the house. Given the square footage of this is the price of the house. Understood, right?
Yeah.
Okay, so this data is given to you. Okay, and the training is happening after you have a new house which is like square footage here, so you have to find the price of the house. It would be something, it would be right, it would be something like this. Got it, right? Okay.
Yeah.
So what you will do, you will actually create an algorithm, okay, which will identify some logic. Based on that logic, you will be able to identify. Let's see further. Okay, let's see further. So regression, this is the problem of type regression. Okay, what is there huh?
Here we are creating some hypothesis for this.
Right. Here you will be creating some logic or some function, which will be when what will happen? Your machine, right? Your software will generate some function. After you have trained it, it has internally generated some logic or function. Using this logic or function, given a particular size of the house, it will be able to predict the price of the house. Understood, right? So what is the output of machine learning algorithm? The output of machine learning algorithm is typically a function, just a function. Okay, a function of one variable with the size. One variable is square footage here, right? A function of this variable whose output is this guy. Function of this variable whose output is price of the house. Okay, and in this case, why is it regression? Because it is predicting real value output. What is real value output? Because it is generating 100 also, 500 also, 222 also. It is generating continuous data. That is why it is called regression. Regression means your price, your sales, all these are regression problem. You have to predict sales of a shop, you have to predict price of something. You have given like you have seen carwala.com, right, where you can put your second-hand car details. It will tell you how much price is it, how much price will you get. This is your car problem. Okay, so this is your car this is your car specific problem. So that is your regression problem. Understood? Because the output is continuous in nature. Is it clear?
Yeah.
Rupesh, is it clear?
Yeah.
Okay, the output is continuous in nature. Okay, the other stuff is classification. Classification means whether it is cancerous or not. Okay, so the output is discrete in nature, 0 or 1. Understood, right? Okay, given a mail, whether it's a spam or not. So output is spam or not, 0 or 1. Okay, or for example, given a particular document, whether this is a sports document or this is a a politics document or this is an entertainment document, so output is fixed. That is known as classification.
Either tells it as a yes or no, like kind of.
Right, yes or no is by classification. You can have more classes as well. For example,
Yeah.
given a particular document, you can identify this is a sports document, news document, whatever is it. 4-5 categories are there, right?
Okay. The previous one is like house price might change up at any time, at any cost. That
Ah,
algorithm is called regression one, right?
right. That is called regression. Okay, that means the output is continuous in nature. The output can be one also, output can be 1 million also. You don't have a fixed set. In the classification case, you have a fixed set of data, isn't it?
Yes.
Got it, right? In classification, you have fixed set of data.
Hmm.
Okay, and in regression, you have increasing data, or data can have any number. So house price is a regression case. Given a size of the house, you have to find the price of the house. It can be anything. Fine as of now.
Yeah.
Okay, so let's take a case. So what you see here, you have this guy, right? Andrew Ng.
Yes.
Okay, so he is very famous in the area of machine learning, deep learning. I use a lot of his contents, and I of course have to give due credits to him. I am not the creator of these slides. I'm using his slides information. Okay.
In Coursera, I have seen.
Yeah. I just, because he have written very good notes. For training purpose, I find it really awesome. So all due credits to Andrew Ng for creating this. I'll use a lot of his contents throughout. Okay.
Mhm.
Okay, and I'll share some other contents from other professors also. Like this is one page, which you can. I'll share you this. Okay, so this is one page where you find all the maths that is needed. Okay, because it's difficult for me to, like, I'll ping those stuff. It's difficult for me to write those math in the screen. I can do that on the board, but in the screen it is difficult. So I'll use the contents that is shown up here. Fine, right?
Yeah. In Coursera, I have seen that is very good.
Yeah. So I'll use the same maths. I'll use because that is pretty much that is required, more than required. Okay, I'll explain you whatever is there. Okay, at least in the foundation course, some part of it.
Mhm.
Okay. So after this, if you want, you can revisit Coursera actually. So if you have missed out something, you will be able to understand that. Okay. So let's see. Okay, what you have? This is your total number of. This is right. This is your total number of test cases. This is one test case, second test case. This is your square footage of the house. This is the price corresponding to it. Okay, so what M is total number of examples. Okay,
That is
X
the
X.
data I give. Like
Huh?
input I give.
Yeah, this is input. Training data. Okay, because when you are creating a software which will predict the price of the house, you have to train it first. For training the software, okay, the way your parents trained you to identify cat and dog. Okay, so you have to train the data first. So if you have to train the data first, okay, train the model first. So you have price of the size of the house, the price of the house, size of the house, the price of the house, size of the house, the price of the house, size of the house, the price of the house. Okay, X is the input variables. This is your X. Okay, Y is your output variable. Okay, Y is the price of the house. Understood, right? These input variables is also known as features. Remember this technical jargon. This input variables is also known as feature. As of now, you have only one feature. You can have many features. Like you can have a number of bedrooms, number of bathrooms, right? You can have many features. As of now, for simplicity, I'll be using only one feature. Fine, right?
Yes.
Okay, and gradually I'll make it more complex by adding more and more features.
Okay. So from this, we have to create the function.
Huh? Oh, wait. Just give me a few minutes. I will be reaching there. Okay. Just get the technical jargons right. Okay. Just few minutes. Okay. So the output is your target variables or output variable. Okay. Remember this words. Okay. So what you have to do? This is what you are asking. This is what you're asking. So what you do here, you typically have to find that, see, this is a training data set, this is the learning algorithm. Okay, so for example, we use linear regression in this case as one learning algorithm. So imagine this as an empty brain when you're born, right? The empty brain without any learning, this is it. Okay, the empty brain without, this is empty brain without any learning. Okay, now you are training it, your parents are training it. So what it yields a logic in your brain. That means you created some complex logic, okay, and which will be able to predict price of the house given a particular house. Understood, right? So this part is known as hypothesis academically. Technique in the practical world, this is known as model.
Okay.
Okay, academically what he says, I mean, that's what Andrew Ng is, of course, academic person, so that's what he will say, hypothesis. But in industry you will not say hypothesis, you will say model. Understood, right?
Okay.
Okay.
Okay, this is your testing data. This is your prediction. So,
This function, whatever is there,
huh?
the function, the model, will I going to write a program for that?
No, yeah, I mean, you don't have to write a program, but you'll write code for this. I'll get there in a few minutes. Okay, just few minutes.
Okay, so in training set, actually what data we are giving? The size of the house?
In training set you have given size of the house and price of the house.
Okay, okay.
Okay, okay, so here you will be size and price, and here you will be testing data. Here you will be giving only size. Okay, only size you will be giving here, not the price.
Okay, so the thing is, once in training set we are giving size and price, then through learning algorithm we will be creating the model, right?
Right.
And once we create the model, then any kind of size of house, it should give the estimated price.
Absolutely.
Okay. Okay, fine.
Okay, let's see further. Okay, let's see further. So okay, see, let's see here. So now what we have is in this particular case, okay, in our case, what we have to do, we want to predict, in this case, right, what we want to do, we want to predict that, okay, how many variables are there? Only one variable, right?
Yeah.
Okay, that means given a size. So what you want to predict, we want to predict that straight line. Okay, we want to predict that straight line, which using which we will be able to predict our price. Okay, if we find out a straight line which represents data like this, given a price size of the house, we can very easily find the price of the house, isn't it?
Yeah.
Okay, so what you have to do, you have to find this straight line. What is the, understood, right, Rupesh? Okay, so this is not all, this is the simplest case. So just assume, okay, so your model typically is saying, your learning algorithm is, suppose you are telling it that I want straight line. This is where you will tell what you want. So you can tell here that you need curvy line also. You can tell here you need something else as well. So what you will tell in your learning algorithm, okay, what you will tell in your learning algorithm, that you need a straight line, right? Okay, you need a straight line. Okay, so when you need a straight line in the learning algorithm, okay, then what will you predict? You will predict this straight line. Okay, this you can see here, this straight line you are predicting. Okay, this straight line you have to predict. Okay, what is the formula of straight line?
X equal to y.
Y is equal to mx plus c.
Yeah, right. So in Andrew Ng world, you call it, your theta 0 is your intercept, that is c, right? Theta 1 is your intercept, sorry, slope.
Okay.
Okay, so slope is this slope, and intercept is wherever it is intercepting y-axis. In this case it is minus something. Okay, so this is the equation of this straight line. So what you have to find out, to find the straight line, you have to find the theta 0 in theta 1, isn't it?
Yeah.
Okay, what you have to find? You have to find value of theta 0 and theta 1. as you can see here. Okay, if you find the value of theta 0, theta 1, you have found out the line for you. So what are the possible options of theta 0 and theta 1? How many possible options of theta 0, theta 1 are there? Given a list of points like this, how many lines can you draw?
Only one.
Huh?
I didn't get it.
So suppose you have these data points. You have to find a line which will do the prediction for you. How many possible lines are there?
By joining all of them.
No. You have to find a straight line which can do the prediction for you. So how many straight lines are possible?
Many would be there.
Huh?
Many would be there.
Exactly, many. Infinite actually, not many. It's infinite. The answer is infinite because there is infinite possibility of theta 0 and theta 1, isn't it?
Yes.
Yeah.
Yes.
Okay, because there is infinite possibility of theta 0 and theta 1. Now, okay, now for such possibilities of theta 0 and theta 1, okay, so let's see what you have to, but which now the thing is, okay, now which line is best? That is the thing. Okay, so this is the case. So we have to find out the possible values of theta 0 and theta 1. Okay, what you have to do, you have to find how to choose theta 0 and theta 1. That is the next question. Understood, right? Okay, by having different value of theta 0, theta 1, you will get different lines like this, isn't it?
Yes. Yeah.
Okay, and remember, intercept is your this point. This is your intercept. Okay, this is your theta 0. Okay. Okay, so it might look very daunting math, but it's really simple. I will explain it all. Okay. Okay, so if you know a little bit of maths here, it becomes very useful to understand a lot of internal logic. Even if you don't understand and you understand what code I will write, even that also is fine. Okay, so I'm just feeding this information. Let me know if it doesn't work out. Okay. Okay, so what you have to do, you have to find the value of theta 0, theta 1, okay, such that there is something known as cost. Okay, cost of each line. Okay, what is cost of each line? The cost of each line is typically, see this diagram. What is cost of each line? This is the actual value, isn't it?
Yeah.
Okay, the cross, this one is an actual value. Okay, so for its size of house is this, but the price of house is this, isn't it? But this is the line that was predicted. Okay, if this is the line that was predicted, if the size of the house is this, what is the cost? This cost is this much, isn't it?
Yeah.
Similarly, if the price size of house is this, the cost is this much. The predicted cost, the actual cost is this much. Similarly, this is the actual cost. This is the predicted cost. Okay, so for this, you have many options of lines, isn't it? Many lines, many combinations of theta 0, theta 1. Which one will you choose? You will choose the one theta 0, theta 1 for which there is this cost, which is least. What is cost? Cost is difference between actual value and predicted value. Okay, this is actual value and this is predicted value. Difference between them, this can be positive and negative both. Square of the difference between them. Okay, and sum of all of them. This plus this plus this. Is it clear?
Can you repeat again? Hello.
Okay, understood, right? So see, why are you, the first question is why. See, this is the maths here. Okay, sum of, this is the actual value. Okay, and this is the predicted value. This is actual value, predicted value, predicted value, actual value. So square sum of all those squares. Can you tell me why am I doing squares here?
It will make there will be no negative value.
Absolutely, and for that you can do absolute also, right? ABS. And what else can you do? What else can be the possible reason?
We are making a square, some mean something we're making.
See, the reason of squaring is more significant numbers become, less significant number becomes further less significant, and more significant number become more significant. That is the rule of square, isn't it? If you have 0.0001 square, that is that will become very less. But if you have 0.1 square, that will become little more significant. I mean,
Okay,
little less significant.
as you told in the last figure, here we in example we are seeing like only for example uh, like whatever we had predicted the line black one. Okay, so here we have 3 points like whatever is outside the prediction. So here we are taking just for 3. If it is like millions of points are outside our
Yeah,
straight
yeah.
line,
You have to
is
take
it
for millions.
okay, then how it is possible to calculate like this?
No. You have machine learning. That's what I'm not. There is. You don't have to write all this code. There is software. There is
Okay,
APIs which will
okay,
be doing this for you. Okay.
okay, yeah, got it.
Okay. So understood what is this is. You are doing a square of the difference and sum of the square of the difference, and essentially you are doing a square root of it all. Okay.
Square
So
root of
this is the cost function actually. Okay. I'm explaining it in a minute. Okay. If I show you. This is the maths here. Okay, so difference between the actual, the predicted price and the actual price, sum of all of them. Okay, so this is the cost function. Understood what is cost function? This one is residual sum of squares. Is it clear?
Yeah.
Okay, for every possible lines, you will find one cost function. I mean, for every possible line, you will find a cost, isn't it?
Okay.
Okay, for every possible line, you will find a cost. Okay, so different line will have different cost, isn't it?
Like predicted line you were telling, right?
Yeah. This is one line. You can of course have, this has one line. Sorry, this
Okay,
has
yeah,
one
yeah,
line. This has one line,
yeah.
right? So for different line, there will be different cost. Okay, so cost is a property of line. That means every line will have a different cost. Which line will you choose?
One doubt.
Huh?
After all the calculations I have done, now after doing this cost function,
Hmm.
I will have only one possible line, right? Because by then I would be having all test data calculated.
Mm-hmm.
Like,
Yeah.
so out of all other possible lines, now I have made one line, one straight line. Is it right? Or still I'm in confusion of finding different lines.
No. See, you have what are the possibilities? There are a lot of possibilities of line, right?
There are
Which one will be
actually
the best?
lot of possibilities before the data I got, before the testing data I got. Now I got some testing data.
Hmm.
After
No,
that,
no, 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 no. No. I mean, testing. See, testing. Don't call it testing data. Call it training data.
okay, yeah,
Okay, training data, because you are training the model. Okay, so when you are training the model, you would line such lines, these lines, right? These lines will be predicted. These lines
yeah,
will be, this. Okay, these lines will be obtained only after you are training the model. Okay.
okay,
Okay.
okay,
So, okay. So just forget that part. Just I'm asking if you have many lines at one point of time.
yeah, okay.
Okay. If you have many lines at one point of time, which line do you choose?
I have no clue.
Hmm?
Maybe which is reality, near
Ah,
to reality, kind of.
Where the residual sum of squares will be minimum.
exactly. Okay, perfect. So that is what. So you have, I mean, that's what, right? You have many lines, but you'll choose the line which is,
Near to the,
least cost function. Got it, right,
yeah,
Rubesh?
okay, yeah.
Hmm. Which has the least cost function. Exactly. Now you are getting the nerve of machine learning here. Okay. So there is a lot of so you can see. So if I'm see for simply let's explain what is happening here. Okay. So now for simplicity, I have taken theta 0 is equal to 0 for simplicity, because anyway that is intercept. Fine, right? Okay, so your the cost function becomes something like this, j theta 1. Okay, where theta 1 is your intercept slope. Okay, so when you use theta 1, this is your cost function. J theta 0 means, okay, this one j theta 0 means cost function.
Okay, so this graph earlier we were doing input versus output, and this is our theta 1 versus j theta 1.
J theta 1 is cost function.
Okay, and theta 1 is the slope.
Absolutely.
Theta 1 is the slope.
Okay.
So yeah, theta 0 we told about the intersection. Slope, how we will make it, like for example theta 1 whatever slope, like theta 0 we got, like whatever it is intersecting, but slope how to judge, like what will be the value of theta 1?
Theta 1, like, I mean, what we are doing, I mean, no need to predict value of theta. I mean, no need to do anything with theta 1. So like, your function is something like this now. I mean, your function is y is equal to, okay, theta 0 plus theta 1, okay, theta 1 x. Okay, so y is equal to theta 0 plus theta 1 x. Okay, so for easier calculation, we have made theta 0 is equal to 0. So what is y? Y is your theta 1 x, isn't it?
Yeah.
Okay, and the cost function of this line, y is equal to theta 1 x, is j theta 1. Understood?
Yeah.
So for different value of theta 1, this is the cost. For theta 1 is equal to 1, the cost is 0. That means it is touching all the points. When the cost will be 0?
Then, hello.
Yeah, when the cost will be 0 for a line, when the cost will be 0 for all the training data.
When slope is 0. Okay.
Hey, cost will be 0 when the line is touching all the points, isn't it?
Yeah.
Then if line touches all the points, this minus this will be 0, this minus this will be 0, this minus this will be 0, isn't it?
That is perfect.
Okay.
Yeah, that is perfect line as of now. Later on we'll understand more things. As of now, there is a perfect line. Okay, let's see. Okay, so one thing, if you're not following me so far, that's okay. I mean, just because don't get demoralized because I'm talking about maths here. Machine learning is not all about maths. Maths is one part of it. Okay, so you can there are a lot of other ways to do various things here. Then we can come back to maths later on as well. But let's see further. So theta 1 is equal to 1. The cost function is 0, as you can see here. Theta 1 is equal to 0.5. The cost function is something like this. Theta 1 is equal to 2. The cost function, we will plot something like this here. Okay, so for various theta 1, you have various cost. Got it, right?
Yeah.
Okay, like if you are plotting a curve for various cost, you might get a curve like this, isn't it?
Yeah.
Okay, how this graph came?
For theta 0, theta 1, 1, this is the cost. For
Okay,
theta
yeah.
1, 1.5, this is the cost. For theta 1, okay, so you plotted the curve. Is it clear, Trupesh?
Yes.
Okay. Now, okay. So now, when you plotted this curve, okay. So what is the value of theta 1 which is best for you?
J of theta 1 1.
Exactly, theta 1 1. So theta 1 1, or the point in this is a curve, isn't it? The point in the curve at which the slope is 0, isn't it?
Slope is 0.
Yes.
Okay, at this point, what is the slope? What is the slope at any point? It is a tangent at that point, isn't it?
Yes.
Yeah.
Okay, so what is what is tangent at a point? It is and we're doing little bit more maths. If you have a slope curve like this, and if you want to find slope at a point, Okay, so if you have a curve like this, okay, if you have a curve like this, and if you have to find slope of a point, okay, so what will be the slope at a point? That is d by dx, isn't it? Remember d by dx?
Yeah,
Derivative.
derivative.
Yeah, so so what does it mean? D by dx or at a particular point is the slope is the slope of that curve, isn't it?